Hey, look at this. Done with FreeCAD 3D printing, laser cutting, and a good dose of tricks. I'll show you in detail how I did it so it could inspire you. Hi, I'm Gathried. Today, I introduce you to a funny project that I did recently because I had a little time. I created, from the logo of my sports club, the CrossFit Moratum, a light sign of pretty nice size, 450 mm by 450 mm. In this video, I will show you all the steps and tools I used to achieve this result. So we'll see how to convert a bitmap image into a vector image, how to make a 3D from that vector image. We'll look at how to do a little rendering under Blender of that kind as quickly as possible. So now he's calculating himself live. And then I'm going to show you, in fact, all the steps under FreeCAD 1 because we installed the latest version this time we're there. To make all the parts of this light sign. Little challenge, namely that I have at my disposal only an old Ender 3 as a 3D printer, so with a 220 mm by 220 mm tray. And my box bag for laser cutting, where I currently have a cutting surface of 340 mm by 260 mm dot. So you see, my little problem is I can't do the whole thing in one cut. Okay, first step, I'm going to show you how we're going to convert any image into a vector image to be able to use it a little more seriously after, to make 3D construction. For that, I used Inkscape, a great open source software that has existed for a long time. We're not going to go into the details, so version 1.4, how's it going? Actually, it's pretty simple. Take your logo. You can adapt it a little bit, so we press Ctrl to keep the proportions. And then in Inkscape, there's a great tool called Trace Bitmap Dot. So you click on that, and then there are the thresholds to be set. For detection, you can also set different things. Basically, it's the sharpness of the cut. You just do apply, and then it makes you a vector image that you're going to be able to use. So you just take this image, have export it to SVG. And that's it. So you have your image that is converted to SVG file that you can then use in FreeCAD. Now we can move on to FreeCAD. So to demonstrate, I'm going to create our files. And now you're actually going to be able to import that SVG logo. So you import it like a SCG geometry. And here you have the elements that are there, that appear. And then thanks to that, you're going to be able to create 3 directly. So it can be as simple as taking the part workshop one side and extrude it like a solid in direction Z. There you go. I think you have understood the principle of this first step. So I don't show you all the details with the full logo, but on principle that's it. And you can then use your volumes, either positive or negative, depending on what you want to do. That's what it gives once you've taken the time to do the job right. And then what I just did was that I drew a frame that surrounds the global logo. And then I cut out my volume of the logo in my frame. And so it gives me the front face of my logo. So, I repeat, maybe it wasn't very clear. So it's your logo in positive. Here, you have your wooden board if you like. And you make a cut, the logo in positive, in the board of wood. There, we are now at the first concept of launching a light. So we've got the front face. And behind I made a box with. So we come and put on a bunch of neon LEDs. The idea is for the light to reflect diffusely on the bottom of the box. Through the front face. So nothing special to say. What can be interesting for you? For the box, I used the thickness function. So I just made the volume, and then I dug the inside. It's very practical. I'm just showing you the principle. We need to know that. So you're creating a body. You make any volume. Here's a rectangle. There you go. And so it's that function. It allows you to dig inside. Then you can adjust the thickness. So in my case, it was very practical. Because I took the outer contour of the box and then I dug the inside. There you go. This might be something interesting for you. For the light strip. Yes, there I used a nice little feature. From the Sketcher workshop. It's the detour function. So let's take my example here. You can take any sketch. And then you can either develop it or reduce it. So it's very practical. So, right now, I didn't get a copy. You check the original geometry team. There you go. Go from the center. And it allows you to do a clone expanded your profile. That's the concept. Global. Dot. So that's my first model that I used then to make a rendering. To be able to propose the project. So my first volume conceptual was ready. From there, I just have it exported in STL. So you're doing file export STL. And then, so you're doing this with the three pieces different. Front face, the bottom of the box, and the wool band. And then be able to import this in Blender. I'm not going too much go into detail from Blender. It's just to show you that to make a surrender, it's the software. Open source you need to use. So here, I used Blender 433. So, I imported my 3Ds. I made a fondue, which simulates wall, where we're going to pose the logo. And then after that, we just have to configure actually each 3D with different materials and different colors. And there, let's move on. In the mode rendering, it's a little hot at the level of the graphic card. So, as I told you, you have to configure each material. For the rear wall, so I took it. A texture to make a rendering drink. Front face, we just have defined a color. Color black. For the bottom, I've defined a white color. And for the lead strip, that's right. Which is the most interesting. It's defined one color emissive. So, at the level material, there you go. It's here. The small option issue. You can choose color you're giving him. And you can ask her to the extent that it's either emissive. So, it's like if it were a source light. And this allows of the simulate rendering in such a way it's pretty realistic. So here, we're live. With the recording video, it's a little bit hot. Graphics cards who have the penalty to be followed. If we're gonna get him, let the time go, you see. That rendering appears. We can change color of the band LED. So that's what makes it possible to do a rendering nice enough. So I did. My little ones. Re-rendering, and then I've offered my little project, and it was nice. So you can throw me in the future. There you go. We're coming back now in FreeCAD. We haven't got it yet. Too much talk of size. For now, I just had used my SVG without looking too much what dimensions it was. So we were on about 170 mm of length. What makes a little bit. Kid. To adapt size of my logo without too much to bother, I used clones of the workshop draft. It's also a tool to know absolutely. So, if you take your 3D, you can actually directly adapt to its size by doing a clone that little sheet. Then, you can adjust the scale in such a way non-uniform actually, if you wish. You can take your form here only in X and now in Y. So that's what makes it possible. To adapt size of your 3D without everything I have to do it again. So it's very practical. So this, we're gonna close. This. So that's what I did. Here. Volume initial, and you have here volume final proposed. I have, by the way, done a little plan with the workshop tech drawer to give an idea dimensions of the project. But in the end, I did it. A little bit more larger. Let's see. All of this. So here, we're gonna hide our initial 3D. And then here I had fun. To be undertaken a small animation just that I'll find it. With the workshop exploded assembly. Just to illustrate the principle of the project. So, the box, the lead strip, and the front face. That's the first idea. There you go. Let's pack it up. There you go. If ever, small useful workshop also to know. Alright now, we're moving on. Serious. So once the project has been completed, Andrei Gumevo had to accept. Let's get started. In manufacturing. So after a first test which has passed in. That I was able to cut at one time in my surface of work. So, 340 mm paragraph 260. We found him. With my son a little small. So, we've decided a little bit boost the waist. So, we stopped on a dimension 460 long for almost 400 high. But the problem purely technical, it's just that so much to do the framework in 3D printing to come and welcome the milk band. I've only got a little one. Creality Ender of 220 para. 220, I don't know what you're talking about. And my laser cutter, I'm limited. At this surface of work, it's got to be that my shape be achieved in several times. So I had the idea to do the puzzle. So I used two techniques, different puzzle for the front face. As I used cross-sectional panel poplar for Maven thick, it was anyway. A little weak, so it was good. Double the thickness. So I did. Shoom. I cut my front face in 3 different rooms. With a first cut which follows design of the logo, and a second cut technical to come strengthening the back room. So it was for the front face. So I did. These 2 cuts there. I'll show you. Right away, I'll see you later. How we do it in FreeCAD to do this kind of thing. Operations. And for the frame, so here, I extruded a nice profile, 35 mm thick, with a good surface gluing in order to be able to do so. Come and put my lead strip inside, and that's what it's all about. A finish, a little clean. So here, I used the same technique. So, I did. My whole room. And then I cut it out. In small pieces so it'll pass. On my set, 3D printer. And for the bottom. There. I didn't mean to. Reuse this technique puzzle double layer. So I did. A true cut puzzle but simple layer with follow-up puzzle type, but with the same technique at the level 3 modeling. So it was the main elements. The last detail who's got me. Griefed a little bit. It's how is it? We're coming. Fix the inside of letters because you see there in design, there's no of attachment, there's nothing. So you can do your cut laser. But then the inside of A and R, he's not going. Hold it all by yourself. In the air. So talking with ma'am, I've been offered to do 1-piece plastic transparent. So I've got used PET, what is a very good idea. It made me feel better. To come paste actually. My face back that allowed me to do that. To paste the inside of my letter behind front face with a substance transparent and incoming paint front face, that's what makes it possible. To do effect which renders as the original design. So we're coming back on the principle of the cut. That's it. It's very useful. Modeling 3D. We have to absolutely. That you know that. So, let's admit that you have one volume 3D, let's say anything. A hexagon there. Hop hop, we're doing it. Take volume, and then after OK. After we're going. Extruded still, another face I don't know. It's a long time. Added a small radius, there you go. So if you find in the same problems than me, you have to achieve this room, but that your machine is too much small, I think it's a good idea. You won't do it in half parts, there's a great one. Technical, which consists of, for cutting the room as with a coin cutters, when you're doing small biscuits, and so when it works you're making simply a sketch, another sketch, which follows the route of your cut, so that's it. I'll do that. In such a way, not very intelligent, we're gonna do this. Like this. So that's it. We're running away. You can see by where we're going, and after in the workshop share actually. You're going. Extruded the trait, and it gives you the plan of a kind used for cutting after there's. A great one. Tool which is called Slice Part, which allows really cutting your room in two pieces using your coin cutter, so you select body and cut the profile of a kind used for cutting select function, and there you go. You find yourself with two pieces which are usable in such a way totally independent. It's really hyper practical, you have to know that. There you go. Now we've seen it. Outline all principles modeling 3 used in this project. Now I'll introduce you. Still, how concretely we're programmed. Machinery to achieve parts so, on plates, cutlery, laser, and also parts printed 3D, just for culture. I think a lot you know how to do that. Maybe. That some discover so, for parts printed 3D, I'm using Orca Slicer so, that's all. Simple so, you select a profile machine you know. The tray there. And you take your parts, you position this on the set after you select parameters of solidity, whatever you want use, and this make you truncation of your room so. There. We see all layers of the coin, and now almost the subject, the most interesting of the project programming laser cutting, I'll show you. How does it work? I did that. So, I used the workshop cam, formerly past FreeCAD. So here you have e.g. this room of the panel yesterday in green, you have the course tools I'll show you. I think it's a good idea. There. In detail workflow that I use for programming these cuts because I think that's what I'm talking about. Of interest, so how it's going if we resume parts examples that I used before you are in the workshop cam here. So I was saying first point to be observed, very important when you do of machining 3D. It's about positioning. Your room in relation to on your surface working group, so me. I've got one surface working group which makes 340 mm in the x-axis and 260 in y. I think it's a good idea. By putting in like this, I've got my play, which is in the area working group. I think it's a good idea. I'll be able to create my job there. I think it's a good idea. Let's take it. This volume there. Hop, 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 there you go. So that's it. It's going to be the area of a kind used for machining which is created, so we select the controller of our machine Marlin in this case. At the level of the tool, we define advanced speed. So we cut laser 200 mm in the movement of persons horizontal and also 200 mm in the movement of persons vertical. It's a laser. So there's no of rotational direction. There you go. There you go. We're ready. So here it's 0. Machine we want to cut, actually. The profile of the coin, so we select this surface. And then here we've got a tool. Profile, so geometry base. It's the face. There. After you can choose actually. Depth of a kind used for machining, I'll put it on. I laser actually. 0 on my board, so height of departure I want her 0, and I'm going down at -0.1. By not of 0.1 like this. Actually, I'll stay on the same height here. That's the movement between operations of a kind used for machining, so we're going to define heights a little normal 5, 4, then they say, okay. And there you go. You have your tool path which has been created there. Around of this room on the other hand, there we see. He's out of date, because I forgot to change diameter of the tool, so, because in fact we're simulating machining, so let's try tool simulation, a small simulation there. Then first passage through the material, and there you go. It's simulating our cutting of the profile. Then we made a volume. We're gonna fire. And as I said, I forgot to change diameter of the tool because as standard it's at 5 mm and how it's a laser actually. In theory he's doing 400ths, but I'll put it on 1/10, and there you go. Our journey tool, it's close, and there you go. We've got our own tool path, which is made. I think it's a good idea. Then, so that's it. We select the program of a kind used for machining, then here, with this icon, there we can go get it. The program, so that's it. You have travel of your CNC programmer cutting of your room, so me. What I'm doing, it's because I'm getting back this code, and then I'll track him down a little bit. I've got a few little ones. Orders custom, so I'll add for now on the bot bag. I didn't put it on. Switch end of race. So I'm positioning my tool actually at 0 point, and with the command 992, I define on 0 as being the starting point of machining, so that's it. I'll add it manually after the blow and for enable laser actually. The little laser head that I'm using is piloted by a PVM, so actually I can just take one exit fan of the map, so it's one card pilotage printer. 3D classic, so by taking the exit of a fan actually. We can. Directly we've got a PVM, a signal PVM who's going out there. So it's with this command I'll activate it. So it's 106/200, so we can adjust the intensity actually. From 0 to 255, and then there. That's what makes it possible to activate laser at about 70% power, and then after I'll start my cut, and then at the end cutting I'm stopping. Laser, and there you go. So that's it. It's an example of operations fairly simple, e.g. when cutting head of the lion, there are several elements which are separated, so we have to doing well attention to be activated laser before the course tool well. Stop it at the end. If you don't, you're going. Cut your board between the different operations, so that's it. There's a little bit of it. Working group manual, you have to be well concentrated, know what we're doing if ever you are a little lost and not sure there are little ones. Simulators online, e.g. NC Viewer, which allow to verify your journey's tools after. That's what makes it possible. Sometimes to debug small errors, there you go. So that's how it is that I've programmed my cuts laser, and they're like this. I've shown you actually the totality tools open source that I used in this project, so if we sum up now, we've done it. From of an image, we've done it. A vector image, from this vector image, we've done it. A first room 3D, this room 3D, we've adapted. Its size final dimensions desired in real life, as we were too big in relation to the tools used. We've got used tips and tricks for achieve parts. So by doing a little bit of the puzzle, so cut front face with a puzzle double layer, cut rear face with a puzzle with real follow-up, and cut of the framework 3D printed to accommodate the lead strip and sub-elements who are coming home and a plateau printed, basic after once modeling was over. So we've programmed 3D printer with Orca slicer for manufacture parts plastic, and for parts cut out laser, I used the workshop cam, which is yes, it is. Complete, we'll talk about it. In other videos we can do it. Lots of things. With this workshop here, I'll show you just the case. Cutting laser, so I've generated my journey's tools with this workshop. And as I have a configuration, special startup and shutdown of the tool has been done manually after. Here you go. Like this. We've done it. The turn workflow complete for tools that I used in this project. There you go. Now let's move on to the party implementation. So, laser cutting on the SAK-Bot and done a cover protection to aspirate fumes. So here we see. The first test of a kind used for cutting front face, the one who was too small. There we cut a piece of panel rear we see. Smoke who escapes, so we cut all in addition parts on tile alone, so we're passing by. Through 4.5 mm of a width not exceeding 10 mm, but not exceeding 10 m, but not exceeding 10 m without a problem. It's getting loose. All alone, from time to time, on the rear face you have to give just a little bit. Cuttering for cutting the latest fibers, but generally this there really is. No problem, now we're going to assemble. The puzzle rear face cutting is very precise, well, in the 10th millimeter accuracy, or even good, it's interlocking. Without any worries, there you go. Let's go on. With cutting laser there. The room main head of the ion of the face before the prettiest room mini time-lapse, always at a speed 200 mean cheese seconds once that we've got all rooms of the face before, so the puzzle double layer it's coming together. Simply like this, after I've joined forces. With a little of epoxy, then I'm here. Paste the framework at the rear in which we're going to be able to. Come to fix, lead strips, there you go. Tables gluing deposit of the band lead, I took it. Of the little girl lead strip standard put around of his furniture 5 meters, but still I just have done 3 times the turn, it's not exaggerated, that's what makes it possible. To have a good one intensity, the substance is painted, then with white issuer, so that's it. I'll do it right. Light, but it's still important to have sufficient human rights if we want a good one. Light side on the face before, to optimize contrast, I just have it. Lacquered with acrylic lacquer and one-shot brushes, so all there is simpler anthracite color. Small difficulty ensure than the leads gluing well against the outside duck, so that's it. It's a ready test for rendering a head white wall. We see that we are not bad already. With colors clear actually. So that's it. He wasn't. Still painted contrast wasn't, of course. It's optimal. That's right. That I have decided to paint as in my rendering actually. Front face another actite, and it's of integration of the substance so dimensions play well. They're coming home right now. I did it. With withdrawal of 8mm on the radius, so that's it. Allows of good insert for the substance I did. As for the face before I used epoxy to maintain lead, so I've got used of the grid of aluminium, I dropped it off. All on of the substance I fixed it. First with staples, and after I still have added one layer of hot glue downstairs with a double function at the same time hold the grid and also protect the cutting part because the cut grid there it is. Cutting as barbed wire, it's not very much. Nice for hands then on the product, it's alright. It's alright. But when you do assembly, it's a little bit dislikeful, there you go. So I'll drop you off. Hot glue to maintain this grid well in place, there you go. Like this. We cut each other. Not for indoor use of letters like I told you. I have printed coins in FARC transparent on my old ones. Very old Creality. Lender 7 years old now. But working still a lot of people complaining of these machines. But I'm coming. Still to be drawn from it party, they're here. They're walking. I'm going on. To spin them small blow of deburring colouring of the front buttocks. So first a small marker stroke, and then I'll come a stroke of acrylic. Then I've got it again. Glued the parts with epoxy well in place. This it was well positioned. The artist's claw, and there you go. Bottom closure with the grid which ensures that then the leads won't come back. Stupidly. Thereafter, here's the result. Final, it's varying the color, it's kind of nice. Tell me. The ones you prefer, I have to say that I like them all. Small preference for blue, but still, do you like this content? Then, subscribe. Like, share, comment, I'm very curious to have your feedback for watching this video. Thanks for watching this video.